Before we begin, I would like to introduce my group members. I'm Kasih Anishairah binti Muhammad Nazri, and these are my group members. First, Gisha Juhani binti Ghazwar. Next, Danisa Hana binti Faizul Hasbizi. Followed by Nur Alia Hanim binti Muhammad Zaki. And lastly, Shazrin Shakila binti Saini. Now, we will proceed with our presentation.
Assalamualaikum everyone. Today, we will be presenting about periodic trend in inorganic chemistry. Periodic trend are important concepts in chemistry because they help us to understand how and why elements behave differently across the periodic table. This trend allows us to predict properties such as atomic size, reactivity, bond strength, and polarity, which are essential in explaining chemical behavior. In this presentation, we will discuss how periodic trend influence the properties of elements. The discussion will focus on key elements such as hydrogen, carbon, nitrogen, oxygen, and the halogen. This is which are commonly used to illustrate periodic behavior and reactivity trend in inorganic chemistry. By the end of this presentation, students will be able to identify key periodic trends including atomic size, valence electron, and electronegativity. We will explain how atomic size and bond strength influence the reactivity of elements. We will also describe the relationship between valence electron and reactivity and understand bond polarity based on electronegativity differences and relate halogen trend to their reactivity as inorganic element.
Chemistry is the study of matter, and everything around us is made of atoms. Even things that look very different, like water, air, metal, and plastic, are all made from a tiny particle called as atoms. There are many different types of atoms, and scientists organize them in something called the periodic table. The periodic table is like a big map that shows all the elements in the world in an organized way. When scientists arranged these elements, they discovered something interesting. They found that the properties of the elements do not change randomly. Instead, they change in a pattern. These repeating patterns are called as periodic trend. Periodic trend help us understand how atoms behave. For example, they can tell us which atoms are big or small, which atoms like to attract electrons, and which atoms easily lose electrons. Because of these trends, we can predict how elements will bond, which elements are more reactive, and whether a substance is acidic or basic. So, instead of memorizing every single element, we use periodic trends to understand and predict their behavior. In inorganic chemistry, we study these elements and their properties, and periodic trends are one of the most important tools to help us understand how chemistry works.
First, I will discuss electronegativity and bond polarity. Electronegativity is an atom's ability to attract electrons. Across a period, electronegativity increases, which means elements like oxygen and halogens attract electrons more strongly than carbon. When carbon bond with these elements, electrons are shared unequally, forming polar bonds such as carbon-oxygen or carbon-chlorine. In contrast, carbon-carbon bonds are non-polar because both atoms attract electrons equally. Bond polarity is important because polar bonds are usually the parts of the molecule that react during chemical reactions. Polarity also affects solubility. Organic compounds with polar bonds tend to dissolve better in polar solvents. Therefore, understanding the polar bond polarity helps us predict how organic molecules behave in reactions. Okay, now halogens. Halogens are common in organic compounds and highly electronegative. As we move down to group 7, the atomic size of halogens increases, causing the carbon-halogen bond to become weaker. Although fluorine is the most electronegativity, carbon-fluorine bonds are very strong. Carbon-iodine bonds, however, are weaker and easier to break, making organic compounds with iodine more reactive. Overall, periodic trends such as electronegativity and atomic size help explain bond polarity and reactivity in organic chemistry.
Atomic size is distance from an atom's nucleus to its outermost electrons and change across the periodic table. Across a period, atomic size decreases because the nucleus pulls electron closer, while down a group, size increases as a new electron shells are added. Bond strength is the energy needed to break a bond, and it is influenced by atomic size. Smaller atoms form stronger bonds because their bonding electrons are closer to the nucleus, while larger atoms form longer, weaker bonds. In short, atomic size and bond strength are inversely related. Smaller atoms make stronger bonds, and larger atoms make weaker bonds, which explain trends in stability and reactivity. Valence electrons are the outermost electrons of an atom and determine how it reacts chemically. Across a period, the number of valence electrons increase, making atoms less reactive as their outer shell fills, while down a group, the number of valence electrons stays the same. So elements in the same group show similar reactivity. Reactivity also depends on atomic size. Metals are more reactive when they can easily lose electrons, whereas non-metals are more reactive when they can gain electrons. Understanding valence electrons helps explain the patterns of chemical behavior across the periodic table.
In conclusion, periodic trends are really important in understanding organic chemistry. They help us understand why molecules behave the way they do and why some reactions happen faster or slower. First, electronegativity is important. Electronegativity tells us how strongly an atom pulls electrons. When atoms have different electronegativities, the electrons are shared unevenly. This affects bond polarity and how reactive the molecule is. Next, atomic size matters. Bigger atoms take up more space, which affect bond length and can create steric hindrance. This means that sometimes atoms cannot get close easily during a reaction, which can slow the reaction or change the product form. Then, we have ionization energy and electron affinity. These show how easily atoms lose or gain electrons. Understanding this trend helps us explain reactivity and how reaction intermediate form. Overall, by looking at this periodic trend, we can better predict acidity, basicity, molecular reactivity, and the outcome of organic reaction. So, periodic trends are not just theory, they are practical tools that make organic chemistry easier to understand and more predictable.
This brings us to the end of our presentation. All the information and data discussed were obtained from reliable sources, including textbooks, journal articles, and credible academic websites, which are listed on this final slide. These references were used to ensure the accuracy and the reliability of our content. Thank you very much for your attention, and we are very happy to answer any questions.